All right, guys, section 2.13, solving log and exponential equations. We're going to be taking a look at 4 types of equations in this video. Obviously, you're going to want to add this right here to your notes. But let's briefly talk about these before we get into our examples. So the first case says that if we have an exponential function on both sides with the same base, so it could be like both bases are 2, both bases are 3, any number, but the bases are identical. For the left side of this equation to equal the right side of this equation, our exponents are going to have to be equal to each other. All right, so if it's the case where both sides are an exponent and the bases are the same, we're just going to set the exponents equal to each other and solve from there. The second type of problem is very similar. If there's one log on both sides of the equation with the same base, for the left-hand side to equal the right-hand side, these two portions have to be equal to each other, what's inside of the log. So A and C, we're going to set equal. We're going to ignore the logs because there's only one log on both sides. Now, the last two. So this is the case where either you have an exponential equation or a logarithmic equation, but it's only on one side. So you don't have a log on both sides here or an exponent on both sides. And if that's the case, if it's an exponential equation, we're going to convert it into log form. And if it's a log equation, we're going to convert it into exponential form. All right, so let's look at a few examples here. So first question, we're going to start with exponents on both sides, and the base is the same on both sides, a base of 3. So again, if the base is the same on both sides, you're just setting the exponents equal to each other and then solving for x. So we're going to set x plus 1 equal to 3x minus 5. And then all we have to do is subtract x on both sides. Add the 5 over, and then divide both sides by 2 to give us x equals 3. All right, and that's it. That would be the answer to that first one. So if the bases are the same, it's relatively straightforward. You set the exponents equal, solve for x. Now, the next question, there are exponents on both sides, but they don't have the same base. And so what we're going to have to do here is make both of these have the same base. And typically the way we're going to do that is by making the bigger exponent, trying to write it as the bigger base as the smaller base. And so what we can do is use the fact that 4 to the second gives us 16. And we're going to rewrite 16 as just 4 to the second here. Right, so the smaller base, we're just going to leave it alone. The bigger exponent, or the bigger base rather, I'm going to write as 4 squared. And now we can use our property that when you have an exponent to an exponent, you just multiply those two together. So that's going to give us this right here. So now that we've done that, now that we've made the bases the same, right, now it's more like the previous example, and we're just going to set the exponents equal to each other. So set x plus 1 equal to 2x. And then subtract over x, and we get x equals 1 for the second example right there. All right, third question here. Now we have the case where there's one log on both sides, and it has the same base. So because of that, we're essentially going to get rid of the logs and just set what's inside the logs equal to each other. So we're just going to set x plus 2 equal to that 2x minus 6. Again, subtract over the x, and then add over the 6, and we get x equals 8. Now, the only difference from the first example that we did here, obviously these were logs, is whenever there's a log equation, you have to take your answer and you have to plug it back in and make sure you're getting a positive number inside the logs. And so I can see here, if I plugged in 8, I'm getting a 10 inside this log. And if I plugged in an 8 here, again, we're going to get the same number because they're equal. So we're going to get 10 as well. But it has to be the case that if you plug it in, you get a positive number, right? Because if you think about log graphs, their x-coordinates are always positive. And so we can't end up over here with a negative value once we plug in that number. All right, next question. So we almost have, it's almost like this, but we have 2 logs on this side. We want it just to be 1 log on the left and 1 log on the right. So to do that, we've got to use one of our properties of logs that says if we're adding logs, like separately, if we're adding 2 separate logs, instead of adding those, we can multiply this x with the x plus 1. So we're going to write it like this. X times x plus 1. And then equals that log base 3 of 6. All right, now, again, and we're going to distribute that x in a second here, but now we have a log base 3 on the left and a log base 3 on the right. And so we can just get rid of the logs and set these equal to each other. While we do that, I'm going to go ahead and distribute that x. So that gives us x squared plus x equals 6. Now, to solve a quadratic equation, we don't want it to equal 6. We want it to equal 0. So we're going to subtract the 6 over here. And then we solve quadratic equations by factoring typically. And so we're going to split this into two groupings. All right, the x squared splits into x and x. Now we're looking for what multiplies out to the last number, negative 6, and adds to the middle number, positive 1. And so that would be a plus 3 and a minus 2. Now, once this is factored, we set both of those groupings equal to 0. So that's going to give us x plus 3 equals 0 and x minus 2 equals 0. So x equals negative 3 and x equals positive 2. Now, especially when you get two answers with logs, most likely one of them is going to work, one of them is not. So let's check these. So if I were to plug in a negative 3 right here or right there, we would get a negative inside of the log, which we can't have. And so it's not that one. But if I plug in 2, that's a positive, that's a 3. So it works. They're both positive. So x equals 2 is our solution there. All right, last two. So these are the cases now where the left-hand side is an exponent, the right-hand side is not, and we can't make those have the same base like we did on the problem earlier. We can't make them both have a base of 2 or both have a base of 3. So the only option here is to convert this from exponential form into log form. And so as a log, remember the base is still the base, so the base of 3 is now the base of the log. The other two things basically just switch places, so the 2 goes above the 3, and then the x plus 1 jumps to the other side here. All right, so we're actually going to end up with a log in our final answer. We're not quite done yet, but it is okay with this is a non-calculator question, so we're going to leave this like that. If it was calculator allowed, I would go ahead and find what that is as a decimal. But all we're going to do to get x by itself is subtract that 1 over, but be careful. So this 2 is inside of the log. We don't usually put the parentheses, but it's inside of the log. The minus 1 has to go either after it, or it could be in front of it if it was like a negative 1 plus, and then the log. All right, we're going to leave our answer like that. Again, if it was calculator, we could come up with a decimal here, but we're going to leave it as is for a non-calculator question. All right, last example. So we got a log here, and there's only a log on one side. So whenever that happens, we're going to convert it to exponential form. So as an exponent, this would say 4 to the second equals x plus 1. Again, the goal is to get x by itself, and so we can go ahead and square the 4 to make that a 16. And then subtract over the 1, and we get x is 15, right? That is our answer here. Again, if it's a log at the beginning, you are supposed to double check that if you plug that 15 in, you get a positive number, which we would. That would be 16 in there, so we do get a positive number when we plug in the 15. All right, that's it for this one, guys. Stay flawless.